We're starting a new unit on what is called polynomial arithmetic. Well, arithmetic is very easy to describe, okay? That is adding, subtracting, multiplying, and dividing. But a polynomial, if we break down the word polynomial, poly means many, and nomial means terms. So what we're going to be doing is adding, subtracting, multiplying, and dividing polynomials, or things with many terms. So we're just going to do 3 of those today. We are going to be doing addition, subtraction, and multiplication, but we're going to hold off on division until the next couple classes. Polynomial addition and subtraction is really very straightforward. In polynomial addition, all we're going to do is line up the like terms and combine like terms, CLT. So if I'm adding 3x plus 5 and 2x plus 3, all I'm going to have to do is line up the like terms. Underneath 3x, I'm going to write 2x because that's its like term, and underneath 5, I'm going to write 3. I'm just going to add these like terms. This is going to be 5x and a positive 8. Great, I've combined these polynomials. I've added the polynomials. That's it. You just add the like terms. Polynomial subtraction, though, is when you line them up, you're going to add the opposite. Add the opposite. That's really what subtracting is adding the opposite. It's as if we're distributing a -1, since there's a -1 coefficient right there in front of the parentheses. So let's add the opposite. Well, the opposite of 2x is -2x, and the opposite of 3 is -3. So if I add those things together, I'm going to end up with 1x and a positive 2. 3x plus -2x is 1x, and 5 plus -3 is 2. Now remember, this written on a test, the answer choice will make the 1 coefficient invisible. You are totally cool to write 1x plus 2 or just simply x plus 2. Polynomial arithmetic is very straightforward. Polynomial multiplication is really fun. We're going to learn a couple methods to multiply our polynomials, but today we're going to learn a method called the Punnett square method. Now, those of you who are in biology know what a Punnett square is. Punnett square is something you use to determine the alleles in genetics. I'm using the wrong vocabulary. Mr. Palaio would get on me right now. But let's say that I have the alleles big K, little k, and big M, little m. That means when I cross these two alleles, big K, big M go in the first box, big M, small k go in the second box. On the next row, big K, little m, and in the last box, little k, little m. So basically, you're putting the two pieces next to each other that essentially line up for that box. The big K and the big M line up on this row and column, so big K, big M goes right here. Now that idea is going to stick. However, in mathematics, when two things are smushed next to each other, we're going to multiply them. So when we put the things from the side of this Punnett square into their box, we're actually going to multiply them instead of just writing them down next to each other. So when we're multiplying polynomials, two things smushed next to each other, we're going to line up the first binomial, two terms, binomial, along the top of this Punnett square, and the second binomial along the side. Technically, it doesn't matter which way you put it, but that's how I like to do my math. Now I'm going to multiply the very first two terms. I'm going to do 3x times 2x. Sorry, the bell just rang. We'll let that ring. We're going to do 3x times 2x. Remembering our exponent rules, we multiply the big numbers like normal. 3 times 2 is 6. And we add the exponents. It's going to be x squared. Then I'm going to go to the next box. This next box will be 5 times 2x. Well, that's 10x. First row on the bottom is going to be 3 times 3x. Well, that's 9x, easy. And the last one is going to be 3 times 5. That's 15. Great, we have essentially crossed our binomials, crossed our alleles here. And what do you notice about what's going on right here on my diagonal? Yeah, hopefully you notice that these are like terms. And when I have like terms, I can add them together. 9x plus 10x is 19x. So to write my final answer, the whole thing, you're going to take basically all of the individual pieces, 6x squared, a positive 19x, and a positive 15, and write them as a trinomial or a three-term polynomial, trinomial. The thing that I've just put a nice cute cloud around is the product of 3x plus 5 and 2x plus 3. That's what I get when I multiply them together using the Punnett square method. Great, so our goal today is to make sure that we can understand this Punnett square method as well as adding and subtracting. So let's go into the notes, like on the inside of this little packet that you've picked up. Packet, worksheet, brochure, whatever you want to call it. We're going to do the first 4 problems. It says to write a simplified equivalent expression, because we're just simplifying here, for the following problems by finding the sum or difference. We're going to be finding the sum when you see plus signs. And we're going to be finding the difference, obviously, when you see subtracting signs. Now remember, to find a sum, all you have to do is combine like terms. I find it easiest to write one of the trinomials or polynomials that you have underneath the other one where I'm lining up all of the like terms. Because then I just get to add like old-fashioned way. 3x squared plus 1x squared is 4x squared. Negative 4x plus negative 8x, that's negative 12x. And 2 plus 1, easy, that one's 3. 4x squared minus 12x plus 3 is the trinomial that I get that is equivalent to the question I started with, that I've combined together to find the sum. Pause the video right now. I want you to try number 2. Can you find the sum for the second question? Here's what I got. I moved that second trinomial, the second polynomial, underneath and lined up all of my like terms. Obviously, there was nothing like with x squared, so it gets to combine with nothing and just be x squared. But then I line up my x terms and combine them, and I line up my constants and combine them. Now remember, when we're doing the difference, that's adding the opposite, because subtracting is just adding the opposite. So I'm going to line up all of my like terms, but I'm going to line them up and make them be the opposite. The opposite of x squared is negative x squared. The opposite of negative 8x is positive 8x. And the opposite of positive 1 is negative 1. But then I just combine these terms together. 3x squared plus negative 1x squared, that's 2x squareds. Negative 4x plus 8x, that's 4x. And 2 plus negative 1, that's positive 1. I have found the difference of these two trinomials. Now number 4, I am going to have you try on your own, but I'm going to help you set it up because it is kind of all over the place. If you notice, these aren't written in the normal format. They're not in the right order. We should always have our biggest exponent coming first. So we need to make sure we don't fall for that trick there and actually line up all of my terms opposite with its like term. The opposite of positive x is negative x, and the opposite of positive 3 is negative 3. Now I wrote that negative 3 off to the side because there is no constant in the first polynomial for me to combine it with. Pause the video right now, make sure you understand the difference and can write the difference for this problem. So here's what I got. This one took an additional line of work because when we just straight up combine these in columns with their like terms, the x's, the x squareds, and the constants, it's not in the right order. So I do want to reorder it to be in what is called standard form, where the biggest exponent goes first and then they get smaller and smaller. That's just a little bonus. If you got here, that's great. I would like for us now to start putting it in standard form. So finding the sum or difference is really, that's about as complicated as it can get. We're going to spend a lot more of this time working on finding the products because it's much different. So I didn't set up the Punnett square for you here, and when we're finding the product, which is essentially asking me to find what it is when I multiply these together, I need to remember the steps for the Punnett square. So since I have a binomial times a binomial, that means there's 2 by 2, my Punnett square that I'm setting up is just going to be a normal 2 by 2 Punnett square. Pardon my horrible drawing skills. Along the top I have the first polynomial. It's going to be x and a positive 9. And along the side, I have x and a positive 1. Now, just like on the front page, we're going to cross these things. I'm not going to show the work each time because you guys remember your exponent rules. But to create the first box here, I'm going to do x times x. Well, that's x squared. The second box is 9 times x. See, 9 times x. And 9 times x is 9x. Then I have 1 times x, that's 1x. And 9 times 1, that's 9. What's nice about the Punnett square method is that always along our diagonals, we're going to find our like terms. And there's this cross in the middle that's going to remind me to add them. 1x plus 9x, that's 10x. So my final answer here, my product, is going to be x squared plus 10x, when I combined together those x's, plus 9. That is the trinomial product for these two binomials. Notice how it always goes up in number. If I'm multiplying binomials, I'm going to end with a trinomial. So it's going to get bigger every time because we're multiplying. That's what happens when we multiply. Okay, I just want to make sure we can set these problems up. So on number 6, pause the video and just set it up. We'll come back together whenever you've got it set up and solve it together and multiply it together. But just set it up. Here's the setup. Now some people mess up on this, and that's why I wanted you to try first. This is a 2 by 2 because we have a binomial times a binomial. And when I put 2x and minus 3 on the top, I make sure the 2x goes in the first column and a negative 3 goes on the second because it's negative. Same thing with these rows, 6x on the first row and negative 5 on the second row. You can't drop your signs here, they're very important. Now we're going to cross these things together. When we multiply, 6 times 2 is 12, and x times x is x squared. So I'm going to have 12x squared in my first box. Negative 3 times 6x, that's 18x. Sorry, negative 18x. Come on, Miss Quigley. And negative 5 times 2x is negative 10x. Last but not least, we have our negative 5 times negative 3. That's positive 15. What do I get when I combine my like terms together here on the diagonal? Yeah, you would get negative 28. Negative 10x plus negative 18x is negative 28x. So my product, my final answer here, is 12x squared, the x squared term, negative 28, the combined x term, and a positive 15, my constant. That's the trinomial product of those two binomials. Now number 7 is really pretty cool. If you look at this one, we've made the problem harder, yes. We have a binomial times a trinomial. That's going to change the setup of my Punnett square. Now it's going to be a Punnett rectangle. We're going to have 2 things along the top and 3 things along the side. So I'm going to have a rectangle. I have to make sure there's a place for all of the parts of the binomial and the trinomial. So we have 12x and a positive 5 along the top of the Punnett rectangle. I almost said Punnett square. And we have x squared and 5x and a negative 1 along the side. Now, yes, this got bigger, but the process of crossing and multiplying each individual piece stays the same. Whatever row and column you're on, that's what you're going to multiply. So the first box is going to be these two. X squared times 12x, we have to remember our exponent rules. Our exponent rules say that we should multiply the regular numbers, so 12 times 1 is 12, and x squared times x, that's x to the third power. 2 plus 1 is 3. Then we're going to multiply 5 times x squared. That's 5x squared. Easy. We've got 5x times 12x. 5x times 12x, that's 60x squared. 5 times 12 is 60. X times x is x squared. Next up, we have 5x times 5. 5x times 5 is 25x. Then we have negative 1 times 12x. And negative 1 times 12x is negative 12x. Last but not least, we've got -1 times 5, and -1 times 5, that is a -5. Phew! A lot of little problems here, but again, since we set it up in this Punnett rectangle, what do you notice still happens on these diagonals? Yeah, your like terms are still together. So we can combine 60x squared and 5x squared. We're going to get 65x squared, adding them together. Remember, this is my hint to add. We've got like a cross right there. And since I'm adding 25x and -12x, that would be 13x. If you don't trust me, consult a calculator. Don't let computation be the thing that messes you up. Our final polynomial here, not called a trinomial because there's going to be 4 terms, is 12x cubed plus 65x squared plus 13x minus 5. That's our polynomial product for the binomial and trinomial. There's no like name for a 4-termed polynomial. You just start calling them polynomials. It's not like a quadnomial or anything. So it doesn't matter how big your boxes, squares, and rectangles get, you're still going to be able to use the diagonals to combine your like terms together. It's a very visual way to do a multiplication problem with polynomials. Now, a way we can act like this is an application problem is like number 8. It says, write an expression that represents the area of the shape below. Now, hopefully you remember that a rectangle has an area of length times width. And we're given basically a length and a width. So our question here is saying find the area if I multiplied the length times the width. Oh snap, we know how to do this. This is a polynomial multiplication problem. I do want you to pause the video because once we've gotten past the setup, this problem right here is not very difficult. Pause the video, try it out. Whenever you unpause the video, I'm going to show you my work. That's a lot of work there, but here, let's talk it through. So I set up a binomial times a binomial Punnett square with 5x and 4 from the first binomial, and 4x and -4 from the second. I then crossed these like I cross alleles, again, multiplying numbers, 5 times 4 is 20, multiplying bases, x times x is x squared. 4x times 4 is 16x, and -4 times 5x is -20x. -4 times 4 is -16. I then noticed again that on my diagonal here, I see that I have like terms, and I can always combine like terms to simplify this down into one piece. So my final answer is 20x squared minus 4x minus 16. That is the trinomial answer that represents the area of this rectangle that they've given me. Pretty cool. We're going to spend a lot of class time working on multiplication because the addition and subtraction of polynomials is pretty straightforward, and we've really actually done that for a while, combining like terms and all of that. So make sure that by the end of class that you understand how to multiply our polynomials so that we can really have a good understanding of the basics of polynomial arithmetic. See y'all in class.